All right, let's talk about something that trips up so many people in algebra. You're flying through a problem, everything's going great, and then, bam! You hit an exponent that's a fraction, and the whole thing just grinds to a halt. Well, not anymore. Today, we are going to completely crack the code on these things. Let's get into it. So you see this on a test, 27 to the power of 2/3, and your first thought is probably, what does that even mean, right? How in the world can you multiply something by itself a 2/3 number of times? It seems impossible, but I promise you, in the next few minutes, you'll be able to solve this without even blinking. So a fraction up there in the exponent spot. It looks intimidating, I get it, but here's the secret. It's not some brand new, complicated thing you have to learn. It's actually just two simple operations you already know, just kind of cleverly disguised in one little fraction. And here they are, a power and a root. That's literally it. Every single time you see a fractional exponent, I want your brain to just think power and root. The only trick is knowing which number does which job. Okay, so let's decode it. This right here is the absolute key to the whole thing. And luckily, we've got a super simple way for you to remember it forever. So here's the official rule. When you have x to the m over n, the number on the bottom, the denominator, n, that tells you which root to take, like a square root or a cube root. And the number on top, the numerator, m, that tells you what power to raise it to. And here's a fantastic little trick to lock that in your memory, power over root. Or even better, just picture a plant. The flower is on top, so that's the power, the numerator, and the root is on the bottom, in the ground, so that's the root, the denominator. Simple, right? You'll never mix them up again. Now here's a pro tip. You can technically do the power and the root in either order, but trust me, there is a smart way and a hard way. The smart way saves you a ton of work and keeps the numbers nice and small and easy to deal with. Let's put this trick to work with 8 to the power of 2/3. Okay, we always start with the root, the denominator, which is 3. So we need the cube root of 8. What number times itself 3 times gives you 8? It's 2. See how we made the number smaller? Now we deal with the power, the numerator, which is 2. So we take our result, 2, and we square it. 2 squared is 4, and that's our answer. Let's try another one, just to prove it wasn't a fluke. 16 to the 3/4. Same exact process. Start with the root, the denominator, 4. So we're looking for the fourth root of 16. What number times itself 4 times equals 16? That's right, it's 2. Again, we made a bigger number much smaller. Now for the power, the numerator, 3. We take our 2 and we cube it. 2 cubed is 8. Done. See? It's a pattern. Okay, you're getting good at this. So of course, algebra's gotta throw in a little twist, right? What happens when you see a negative sign out in front of that fraction? Don't panic. You already know how to handle this. It's just one extra super simple step at the beginning. Just like any other negative exponent you've ever seen, it has one job and one job only. It means flip it. You take the whole thing and drop it into the denominator of a fraction, under a 1. That's it. That's all the negative sign does. Let's finally solve that puzzle from the beginning. 27 to the negative 2/3. Okay, step 1, and it's always step 1. See the negative? Flip it. So we get 1 over 27 to the positive 2/3. Now we just focus on the denominator, and hey, we know exactly how to do that. Root first. The cube root of 27 is 3, then the power. 3 squared is 9. So our final answer is 1 over 9. Now that you've got the method down, let's quickly talk about the couple of places people tend to trip up, because knowing what not to do is just as important. This slide says it all. This is exactly why our root first trick is a game changer. Look at the hard way. If you do the power first, you get 8 squared, which is 64. Now you have to figure out the cube root of 64. I mean, it's doable, but why make your brain work that hard? Now look at the smart way. The cube root of 8 is just 2, and 2 squared is 4. Same answer, way less effort. The only other major pitfall is just mixing up which number is which. So let's say it one last time, just to be sure. Think of the plant. The root is down, in the ground, in the denominator. The power, like a flower, is up on top. Okay, so you might be thinking, this is a cool trick for a math test, but am I ever going to use this? Well, it turns out this exact piece of math helps explain basically the entire animal kingdom. There's this incredible thing in biology called Kleiber's law. It's a surprisingly accurate rule that describes how an animal's metabolism, how much energy it uses just to live, relates to its body size. And right there, at the very heart of this fundamental law of nature, is a fractional exponent. This is the formula. It says that an animal's metabolic rate is proportional to its mass raised to the 3/4 power. Just think about that. From the tiniest mouse to the biggest whale, this rule basically holds true. And now you know exactly what that 3/4 means. It means you take the fourth root of the animal's mass and then you cube it. It's not just a math problem anymore. It's a piece of the code of life. So, to wrap this all up, here are the 3 essential things you need to remember. Number 1, power is on top, root is on the bottom. Remember the flower. Number 2, always do the root first. It just keeps the numbers way simpler. And number 3, if you see a negative sign, don't sweat it. It just means flip it before you do anything else. And there you have it. You just took one of the most confusing-looking things in all of algebra and turned into a simple, step-by-step process. You've totally cracked the code. So the only question left is, what other math puzzles are you ready to solve now?